Okay, so here's the deal. So, after much soul searching and consternation, we're going to go to the assembly tomorrow. For those of you that are here, for those of you that are coming over from May South, now listen to me. And these you who aren't even here, listen to me. Okay, I have to take attendance. Okay, so it's about making smart decisions. It's actually kind of a cool game show thing. It isn't like your basic normal speaker. So, and here's the reason why. I mean, as one who has led different campaigns in the school, you know, it's important that you have the support of other teachers. And so, I know Nurse Dana went through all this hassle to get it arranged and everything like that. And I looked at it. And if I thought it was going to be a total waste of time, we wouldn't do it. Okay. But from what I've read, and I've watched their promo video and read how they do this, and it's actually based upon brain science and how you make decisions, and because some teenagers do not make good decisions, not you guys collectively, but there are some teenagers that don't.
Fisher doesn't. Fisher doesn't.
Fisher likes to wait till the last minute.
Yeah, living on the edge. Fisher was living on the edge.
This phone.
Yeah. So anyway, so
Where's Sam?
all right. So
He's at a tennis
if
tournament.
you are coming over from May South and you choose not to, have your parents call you out. Do not just not show up because I have to take attendance. Okay, and the same thing for all of you that my normal Mays, not that you guys are abnormal, but the Mays High School students, the same idea. Okay, because I have to take attendance. And here's the reason why. It's like, well, I can't tell you, I just don't show up. And then speaking of car accidents, somebody, Louis, not that you would, but you get into a car accident and somebody says, hey, why weren't you in school? Burkamp, well, Burkamp said we didn't have to, okay? So this is to cover my liability. So if you're not going to go to it, cool, it's your decision, speaking of making decisions. But have Ma, Pa, Kettle call you out, okay? Because I have to take attendance. So, test is going to be on Thursday, all right? Test is going to be on Thursday. Bob, what I just said, we're doing this assembly tomorrow. If you don't want to go to it, have your folks call you out.
Oh,
But the test is going to be on Thursday, huh?
During this whole class?
Yes.
during the assembly? Okay.
Yeah. So if you don't want to go, then have your folks call you out. Okay. Just don't not show up. Okay. Pop, did you hand in that lab, that yellow lab?
I have it.
Okay, I was flipping out because I thought you handed it in and I couldn't
No,
find
I
it.
got
And
it.
I went to grade it and I thought
Okay.
that
No, you do it.
if you want to hold on to it and then hand it in the day of the test, that's fine, whatever you want to do. I just wanted to make sure that I hadn't lost it.
I have it done.
Okay, that's what I was kind of flipping out about. Okay, so
My bad.
let's talk about this question number 15 out of the book, okay? Because this is the type of thing that you're going to be able to have to do on the test on Thursday, okay? So, here's a couple of things that you have to do, because there's a whole bunch of things that you would have to be able to do. Find the current. You'd have to find the current in each part of it. You'd have to calculate the power in each bulb. And you'd have to be able to rank them, okay? So this one's a little bit complex, mainly because on this one, what I did and how I set this up is that I set the resistance to each of the bulbs to be 10 ohms. And then I set the voltage across the battery to be 40, okay? So let's just work this as it's, let's say that here's the problem on the test. So work this like a small mini quiz. Here are the numbers. Each of the bulbs are 10 ohms, the voltage is 40. Find the current in each part of that circuit. Go.
Right now.
Now.
Like on our.
Try it.
Oh,
No,
okay.
the current.
That's fine.
Now, I'm just saying, this is
Just
what
like
you have to be
random?
able to do on the test. So I want to make sure that I don't want you to look at this problem and go, oh my God, I have no idea where to start, okay? Let me give you a hint. Find the equivalent resistance of everything.
And what's the current? Sorry.
That's what you're trying to find.
No. Oh, never mind. You gave us. Okay.
You got a single 40-volt battery.
Plug-in, sorry.
Everything
Where's
is
my
10 ohms.
calculator?
Gotcha. Yep.
And you wanna find the current in 3 places. Current going here, the current going into these legs, and that current going over there. Start with that. Actually, you have to start with finding the equivalent resistance of the whole thing.
Wait, are we just finding the equivalent resistance right now?
No, he said all of them.
You got to find all of the currents, but you have to start with finding the equivalent resistance of all of them.
I was doing a trench and I didn't realize it was close to this. I'm just
So let me give you a hint. You actually have to do this twice.
Yeah.
You have 2 of these that are in parallel. Find the equivalent resistance of that. Add that to the 10 up there, because that's like having that in series. Then you got that over there, those are in series. Find that resistance, and then add that resistance together as 2 big parallel circuits.
Is it a decimal?
It's gonna be a decimal.
Okay, that's
Yeah,
fine.
all right.
The current and the whole thing will be, well, it's gonna be a very, 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 very good GPA.
Not split between them, just the whole thing.
The whole thing?
Okay. I calculated between them as well.
Okay. You need
checking, man.
the whole current, like as it leaves the battery,
Yeah,
the current going into this part,
yeah,
the current in each of these,
yeah.
and then the current in that.
Wait, I thought it goes that way.
Very nice.
Huh?
I thought that its electrons go that way.
No, this is the conventional old style current.
But does it change it the way they
No,
flow?
it doesn't,
What's the
no, it doesn't
voltage?
change
40?
anything.
Very good GPA.
Yes.
We'll take that one.
I equals.
Is it perhaps a 4.23 or 4.29?
No.
Oh, I think
Um,
so.
I'm
That's a
really
brilliant
confused.
GPA.
Do
Yeah, that's
1/15
me.
1/15 plus 1/15. What do we get like?
The whole for the whole thing?
Yes, for the whole.
Yeah.
What do you mean, Morella?
I feel like, is 8.57 bad?
No.
That's what it is?
Yeah.
You said it was a GPA.
Yeah,
That's
that's
the
not a
current? No,
GPA.
She asked
that's
about
the
the current,
resistance.
not the resistance.
That's what I thought.
Wait, that's not the
No,
current?
the resistance is 8.
The 8 resistance?
So you do a 40
Okay,
volt,
okay. Sounds good.
Okay.
40 volt battery.
The current
This is,
through the main part is a very, very good GPA.
Oh, okay, okay.
who's getting that GPA?
4.67?
4.67 actually.
Yes, sir, okay. Okay.
Is it possible on our grade
A
scale to get a
equals-
4.6?
I suppose if you took enough AP classes.
Wait, are APs weighted as 5.0?
Yeah,
Oh,
Jackson.
So for that, for the parallel one.
Which
uh,
parallel one?
The one in the middle.
every
These?
single one
Yeah,
is in there.
so to find that current, would you take the current flowing into the light bulb above that?
No. Okay,
Is it still gonna be the overall current?
yeah, so here's, no. Okay,
Yeah.
what's the current, what's the equivalent resistance of all of these together,
15.
8 point.
15. No, you got 15.
Okay.
right? Because
Yeah,
these two are in
just
parallel, right?
right,
So 1/10 plus 1/10,
right.
and then take the inverse of that,
Uh-huh.
and then add that to 10, and you get
15.
15. So this is like having a single 15 ohm resistor here,
Right,
okay? These two are in series,
right.
so that's like having a single
20.
20. So this is like having a 15 ohm resistor here and a 20 ohm resistor here, okay?
Yeah.
Now, so which one's gonna have more current? The one
That does
going
not make
into
sense.
the 15 ohm or the one going into,
The 15.
15.
okay, so you're gonna have more current in here. So if you wanna do that one, where you do that one, where you take the 4.67 times that quantity 1 minus, and then like that ratio of like,
Oh, okay. I see.
15 over 35.
Is it?
yeah,
is
divided by the whole thing.
Is A gonna be 2.67?
I don't know. Wait,
What do you
Jay?
mean by A? Well,
A.
but going
I
into
mean,
this
the
one-
very top one.
Yes.
And then the D and E, I mean, those two right ones is 2.00.
50
Yes.
plus 10.
Wow.
Okay,
Oh,
Okay, let me do B and C real quick.
greater than,
15
which
plus
one's
20.
which? D, which is equal.
Okay, so here, so
Greater than,
I don't care how, there's a couple of different ways you can think through the current that's going into these. So here's what's gonna be important. Just think through, oh, which one's gonna have more current? Oh, the one that has less resistance is gonna have more current if it's in parallel. Okay? So treat it like that. Now, you, on this one, you get, what did you get, 2.67?
Yeah.
yeah.
Now, so you have 2.67 flowing into here.
But then they split.
Both of these have the same resistance.
So 1.33.
Yeah, so each one's gonna have half that current.
Okay, but I'm confused because why does it not equal 8.57 if it's 2.67 and then 2? Is it supposed to be 2.1?
No, you're confusing resistance with current.
Oh yeah, you're right. Haha, never mind. Oh well.
Louis,
Good question. Okay, so if we were to look at this through the eyes of electrons, how would you explain it? Because it splits off different ways.
yeah,
so it isn't so much electrons, it's the electric field. Okay? We talk about the electrons, but in reality, it's an electron field. So the electrons themselves aren't moving as fast as the current.
Well, I mean, like, since this is the Benjamin Franklin way, the other way.
yeah, if it
is
was
what
going
we
the
do.
other way, how would you?
It would,
find that?
if you just flip it, then the only thing that changes is the direction of the path. It's, the math is still the exact same.
But it splits off
It
3
splits
times
off
instead of
2
twice.
times there. So
But,
how would you find
but
it?
here's the deal, it doesn't make any difference. The field is still going to know, basically, it's almost like it's psychic. It knows that further up there, there's that 10 ohm resistor.
Yeah.
So how it has that knowledge of, if you flip this over and you put that 10 ohm resistor here and then you split it there, the math still works out the same. It doesn't make any difference.
What if we had a problem that, like, we had to solve it like that, though, where it splits off, like, twice?
Could we just turn it around and make it easier? Because you say the math is the same, but it's not. It's in parallel 3
Yeah.
times.
No. Literally, no matter which way this goes, you're still gonna get the exact same answer.
Yeah, but, like, what if we had to do it that way? Going to, is there ever, like, a,
There's no way. That's not the. There's no way because there's 3 branches on the bottom and 2 on the top.
But here's the point, Louis. These, no matter what, these two are still in parallel no matter which direction the current's flowing. Okay, these two
Maybe it has to do
bulbs
with
are
when
still
it's
in
connected
parallel,
in, so
and then it goes
technically
into a
there is only
resistor.
2 branches.
Whether it goes into the single one,
The
if
wires
it's
don't
split,
connect again
it goes
until
like
they're-
this, and then
Because the 3 are in
recombines.
series
It doesn't make any
technically.
difference.
Like, what's
Yeah,
the
but-
other?
Okay.
wait, but
I-
using the,
I get it.
Yeah.
I think we're just reading.
Like, there's in series.
no, but using the logic of, like, it goes the path of least resist, like, it goes more to the least resistance. Like, if you went down and they got to that first conjunction,
But
Wouldn't there be-
what the field is gonna sense is this whole assembly, okay? It doesn't make any difference. It isn't like it gets here and then it makes that decision. The electric field views this whole thing as one entity, no matter which direction that it's flowing.
Water. It's not like that.
Okay, I don't have a set of equations when I have the traditional current and it's going like that versus another calculation if it's going the actual path of the electrons.
yeah, I'm saying it's the same thing, but, like, the logic behind it, if you, like, I'm just saying if you had it, like, what if you flipped it the other way and you were just doing that? Like. you
What
have-
if I flipped what?
If you had if you had 2 branches coming off like that, and that's.
If I had 2 branches like up there and then the single bulb down here?
Just like, what if you had to solve it where it did split off 2 times instead of just.
So okay,
splitting
if
up
you were gonna calculate how much amperage was allocated to each of those branches, how would you do that? Would that
Like
be
here?
20 still? Oh yeah, between those two because it doesn't go through the 10 amp first. It goes through those.
But here's the point. The field that senses this doesn't make any difference which direction that it's going.
Okay.
Okay, that has no bearing on this. Don't get hung up on which direction that it's going, okay? Because it isn't going to sense that it isn't gonna sense two different things. That field is going to sense, that's what I'm telling you. It senses this whole thing as one big resistor.
As 115 ohm.
Yes,
Gotcha.
okay. All right, now, when you look at your power calculations, and I cannot emphasize this enough, you have to be fluid in the three ways of calculating power. What's the simplest one? PIV. Then you have
I squared R.
I squared R, and then you have,
B squared over R.
now, personally, in this situation, I'd use I squared R, mainly because of the fact that then you don't have to mess around and find the voltages, okay? So as soon as you know the current that's going through these, okay, and then if, and this is a huge if, if they're all the same resistance, then if they're all the same resistance, as soon as you know the one that has the most current, you know that's going to be the brightest one, okay? If they're the same resistance, okay?
Yeah.
If they're not, then it turns into a train wreck. It just becomes more complicated. But here's the reason I like I squared R is that that resistance is a fixed value based upon that bulb. Your voltages can change. So if you look at, let's say for example, if you were to look at measuring voltage. Okay, so let's do a little prediction. Okay, so I've got a 40 volt bulb. Obviously, if I measure across the battery, I'm going to get 40 volts. Okay? Now, so if I measure the voltage across this segment over here, this far right branch of that parallel circuit, what should the voltage be?
More than
20.
20? More than
No,
20?
no.
So here are my options. 40?
Wait, less than 20.
Hold on. Here are your options. I'm going to measure the voltage drop across from the top to the bottom here.
Yeah.
So here are my options. Option A is 40 volts. Option B is 20 volts. Option C, it's less than 20. Option D, it's more than 20 but less than 40. So I got 40, 20, less than 20, more than 20. So how many vote 40?
40.
How many vote 20? Less than 20?
I haven't thought about it.
That's what Vitor would vote for right
Vitor wouldn't follow instructions. What's the code word?
there.
The code word today?
Yeah.
Give us some time.
Vote today? Yeah, we gotta come up with that.
Okay, come up with that. All right, so let's see what happens. Well, actually, we got negative 40, but it's the same idea. Okay? Oddly enough, you got 40 volts. Why?
Because it's in parallel.
It's in parallel. Okay, that's it. This is why you wire your houses in parallel so that in the houses it's 120. Okay? Now, I'm going to measure the voltage across this first bulb. What's it going to be?
20.
20.
20. 20.
20?
20.
20, yeah.
20.
20. There we go.
Other one is also going to be
20.
20. Okay, that's cool, right? Now, what if I'm going to take this bulb and I'm going to change it from 10 ohms to say 36 ohms.
It's gonna be around 8.7 voltage.
So what's going to happen? What's going to
Why
happen?
did he know that?
What's going to happen to the voltage across the entire thing?
Stay the same.
Yeah, stay the same. Oh, wait.
Yeah, it stays
Wait, no, no,
Oh,
change,
wait,
change.
Wait,
No,
what
still
do you mean
40.
the entire thing? What do you mean?
40.
Wait,
Yeah.
it stays
It's not
40?
It's the battery,
Oh,
bruh.
yeah.
Parallel.
Yeah,
It's
40.
Parallel. Stays the same. You don't want
But
to
the
blow your
current,
toaster.
But
the current would be different.
the voltage across the 36 is
Different.
different.
Greater
God, I hate you, Lou.
because
So now,
voltage
that
equals
one's
R.
has a voltage of 31.
That's just
This one has a voltage of 8.7. Now, conveniently, what do they still add up to?
40.
Still add up to 40. Okay? Now, this is where, is the current the same through both bulbs?
Yes.
Wait,
Yes.
the current through
Yes.
Yeah.
Yes.
Because no matter
No,
where you
no,
measure
it's
the
not.
current,
Yes.
Yeah, it is.
It's in series.
What? No, it's in parallel.
No, the
Change
two
those-
bulbs, only the
He's talking about
36 and
between
10.
those two right there.
He's just talking about those
The
two.
current's the same through those two.
Oh. Compared to
I was-
when?
Hold on.
That's what I was saying.
No, I'm just saying, is the current through both of these,
Okay, yeah.
the
okay.
36 and
Yeah.
the 10, is that gonna be the same?
Yes, but
Yes.
not as if they were two tens.
Yes, but yeah, that's completely different, because now you've changed the entire resistance of the system,
Gotcha.
Wait, what?
okay?
Well, yeah, but they always have the same current flowing through them.
Yes, as long as they're in
Series.
series.
Wait, what are you? Huh? Okay, yeah, sure.
He's just saying the whole.
I'm
the
just gonna
whole
ignore what
resistance
Louis
would
said.
change.
He's confusing me right now.
Okay,
Don't listen to Louis.
don't
Yeah.
listen,
Louis just-
worse yet,
That's
don't
a
listen to
good rule of
Vitor.
thumb, just kinda like block out everything back here.
Okay,
Louis just thinks out loud.
just, okay, so now, why does that 36 ohm bulb have a drop, bigger voltage drop?
Because Ver.
E equals R.
Because of Ver,
Yeah.
okay, current's the same,
Resistance is higher.
resistance is higher, therefore voltage is
Greater.
nice.
Yes.
Nice, that's varsity work there. Okay,
Varsity.
so this is what you've got to be able to think through, okay? I promise you, I promise you, I promise you. Okay, so when you get to 16, okay, and so Marilla had asked about 16. So if you look at what's happening on 16,
That's a brilliant portrait though. That is great.
no, it's not. That was when I had my hair dyed.
Oh, really?
Did you dye your hair?
What happened to the
year.
must? Hey,
What
hold-
color did you dye your hair?
Well,
Red
it
and-
was red and green.
For Christmas.
He thought we forgot.
I raised like,
Remember how much money we have to
Oh, for the
raise
mustache?
For the mustache.
we'll start that, we'll talk, we'll do that, we'll start
We
that
need at
after
least a
Easter.
month.
Okay.
We need at least a month. It's
Yeah.
gotta be soon.
If we start after, that'll be
Yeah, but
the,
what's the value?
To grow a beard?
Yeah.
I don't know.
no, just do the goatee. You don't want to see it
how
here.
long does that take though?
Mustache.
It'll be pretty noticeable, trust me. So,
Ooh.
yeah,
It's kind of scary.
What? Yeah.
so I'll work on a number. So I'll consult with my sisters over
You've been working on a
Easter.
number for.
Okay. So if you look on 16, you got this action, and then you got like a bulb, something like that. There's your battery, okay? And you got a bulb up here. And so the idea being is that you circumvent this bulb by putting a wire around the outside of it. So you always assume that the wires have no resistance.
Go through that other.
So at this point, when you eliminate those bulbs, because what's going to happen is that now, because this is such a noticeable difference in these resistance, these electrons still obviously have to flow through your first bulb. But then they're going to completely circumvent that second bulb, hop over here, go around here, and then you're off to the races.
Does the question ask you about all three bulbs or just the bulbs in parallel?
It asks about all three.
Bulb A will
I
get
just-
brighter.
That's
Right.
true.
Oh, I
Yep.
thought you just replaced that bulb with a wire.
No, you just hopped across it, like you short-circuited across it.
Is it
So
because
it's still there?
the overall
Yeah, but it's
arm-
just, but it doesn't make any, whether you cut out the bulb and put in a wire, or you hop a wire across it,
Yeah.
it's not gonna make any difference. The electrons are still gonna flow, electricity is still gonna flow through that wire.
Okay, so, yeah,
Okay,
so bulb C would go out.
your answer to 32 is 32?
Is that A?
Yeah,
Oh wait, that's on the
yeah, there's
problem.
it's just
But 32, the
32
other
is A.
32 is A?
30.
Wait.
Problem 32.
Okay.
Problem 32, the answer is 32
Oh yeah.
Oh.
in microfarads. 34 is around the legal drinking age.
Wait, you said problem 32 is?
16?
Oh, my bad.
32.
I thought you were talking about the question.
Problem 32.
Oh.
So I'm 32, okay.
Problem 32, the answer is 32.
Oh, is.
Yeah.
Thank you.
Yeah, it's not around.
That's good.
And the answer to 34 is around the legal drinking age in the United States.
Oh,
not in Ireland or wherever.
Wow, that's kind of disrespectful, actually.
Oh, you gotta admit, come on, Ireland, I've been there, come on.
You've been to Ireland?
No, but I've been to Scotland, but it's all, they're all about the same.
No, they're not.
I know.
How dare you? How dare you? I'm not taking that.
I was just, oh, I just had to throw that jab in there, Louis.
What about 36?
What about 36?
The answer to 36 is pretty close to 36.
Okay, cool. What about question 32? Is it A?
No.
Okay, actually,
Whoa.
can we talk about that one then?
No.
Well, I got A.
I got A
Yeah.
as well.
Can you explain?
I think we all
that?
got A.
Holy Jackson.
Did you get A?
Yeah.
Did you get A, Aspen?
Yeah.
Okay, cool.
Ryder?
Maybe his
Our
answer
kid
key is
trolling.
wrong.
He's
Yeah, it's
trolling
not
right
a
now.
Hold on.
There's no room. It
What's B?
is B. If you say they're both the same,
Hold
I'm pretty
on.
sure it is B.
It can't be.
What even is
Just chill
What even is
out.
the
Current is the same.
This game.
It's question 32.
What's asking
Yeah.
which bulb is brighter? And bulb, the 60 watt, it has 60 watts. and
has
lots
less
of power,
resistance.
doesn't it?
Yeah.
Hold on.
I'm just saying.
We're raging over you right now. You need to be explain yourself.
You're running out of time.
Or what?
We're gonna run off with this money jar over there.
What dollar is it?
The beaker's working.
Oh.
We can pawn it all.
Makes no sense.
Google mutiny.
But 30 is A.
Mutiny.
Commandeer.
30 is A.
Yeah.
It's Chrome.
This
The
physics
Chromebook
is broken.
commandeers.
30, 60,
Wait,
and that's it, right?
so are we actually
Yes.
wrong?
I don't see.
So let me do some.
Doesn't make any sense.
P equals I squared R.
Yeah.
Curve's the same.
Okay. Oh, voltage changes.
Yeah, but the voltage drop for the other one.
Hold on. So
Bugging.
on this one, so when you get to 32, right?
Yeah.
So the supported 40-watt bulb is connected in series, as showing which bulb is going to be brighter. Okay, so here's the story. Are they both going to have the same current?
Yes.
Okay, so I is going to be the same, right?
It is.
Yeah.
And
So the one with the bigger resistance,
Can be brighter.
hold on. The one with the bigger resistance then, if the current is the same, is what Pop said,
Watts. Oh.
is going to be
Right.
brighter.
That's why.
Yeah.
Cool with this. Got that. Now, so when you look at this in terms of you have a 40-watt bulb and you have a 60-watt bulb, right?
Yeah.
So there's more resistance for the 40, right?
Okay.
Yeah.
So if you look at this in terms of the voltage being the same, 120 squared over some R, and then you're going to have 120 squared over that R. Could you find the resistance in each one?
Yeah.
Okay, if you find the resistance in each one, then if you find the one that has the bigger resistance with the same current,
So you can't just look at wattage to see power and
you
brightness.
have to look at what you're holding constant and what you're changing.
Wait.
I just put A.
So
on
if you were
that.
to calculate the power, it wouldn't be 40 watts.
Well, okay.
What's
I was
power?
thinking-
So here's the
No, I was
deal.
thinking it's
I thought
almost
power is
60 watts,
watts.
It is.
but
That doesn't make sense
That's
then.
your books.
Let him explain.
So
Let him cook.
there's two ways. So there's two ways you look at power. It's I squared R. Okay. So here's the story.
That's the key. We're just too typical.
The I is going to be the same for both of them.
Yeah, I know.
Okay.
But like,
So your variable then is your resistance. Okay? The variable is the resistance. So look, run the numbers. So somebody take 120 squared and find that resistance for a 40-watt bulb.
But why is the
360.
Hold on. What'd you get?
360.
360.
Because it's household.
360 ohms, right?
Yeah.
Go with this.
Yeah.
So what do you get for that one?
That's a great question.
240.
Right?
Wouldn't the voltage be 60?
hold on.
The
Sorry.
voltage would be different for each one.
Oh, maybe the entire circuit.
Yeah, so you just, it doesn't make any difference. It does, it's, whether you put 120, it doesn't make any difference. It's all gonna be the same mathematically. Hold on.
The circuit has to.
So this is 240 ohms, right? Cool with this.
How do you know it splits it out?
So the 60-watt bulb has a resistance of 240 ohms. The 40-watt bulb has a 360 ohm. So, and the whole key to this is that these are in series. Okay? These are in series. So if the current is the same, the 40-watt bulb has a higher resistance. So the higher resistance, that's going to produce more power in terms of that brightness. Yes?
But how is the voltage drop the same for each of them if they're gonna be different resistances?
Because of the fact, that's a valid point.
Yeah.
No, it's still, just use I squared R.
Yeah.
V squared over R is a train wreck, as you would say.
That is true.
But if we
For
use
what?
I squared R,
I squared R just makes one.
so we should look at the R for
It's
the
just E
power.
over I squared.
This is really confusing, because I'm like,
But how do you know which resistance?
It's A.
Because the lower the wattage, the higher,
Oh, yeah.
the higher the
Yeah,
resistance.
you can use that. Okay.
So it's
But
just
V squared
gonna
R
be-
is over R is, that doesn't.
Yeah,
So
V squared over R.
So
You
no
have to
matter
know the
what-
voltage drop over
Unless
R.
there's a-
No matter what as long as, if you assume that you have the same voltage drop.
But that would mean the resistance is
But how would they have
then,
the same voltage?
to get the same
yeah, I thought they
current, right?
didn't on when they're in
They can't.
series.
That means the
Punt
voltage.
that question. I won't put that one on the test. I gotta think on that one. Because that's right, because the voltage drops aren't gonna be the same.
Yeah.
Because
you
they're
can
in
just use
series.
I squared R.
Can't you just
know the
do
current's the
power?
same.
I know, because I was
Power
like, that
divided by
question's a
current
little
equals
too
resistance.
easy. Like, they just give it to you
power
right
is
there,
higher
but
once,
like,
so they won't
get the same resistance.
Yeah, forget about 32. That's a train wreck.
Do they not give you an answer key with this book?
They just tell you that it's B. So,
Oh, he's back.
I hope I'm
Whoa!
not doing anything. I just thought I'd say hi.
they let you out of DC?
I'm on spring break right now.
Okay.
So I'm flying back.
Actually, I was just there last Monday and Tuesday.
Oh, for that climate conference.
Yes,
Yeah, that's
so
was that
no
just in a
32.
separate building.
it was at George Washington University, the Milken Health Center,
Oh, okay. Yeah.
right downtown.
Yeah, that sounds pretty cool.
Yeah,
That sounds.
yeah, rode the train.
Yeah, I don't know. Climate's interesting in the Senate right now. They just overturned WOTUS, so.
For,
the waters of the United States
Oh.
classifications. Yeah, it was a Kansas senator who wrote that bill, and it just got passed in the House and the Senate. So
okay.
yeah, that's interesting, but it's pretty cool
But,
working.
have they given you your phone back?
Yeah, I have my phone now.
Okay.
Only for spring break, and then I have to get it. So like on Friday, I got it for the first time in 2 months.
You got
Haven't
like a
touched it
flip
since.
phone then? How do you call people?
They have like a landline.
We have a landline in our room.
Wait,
Oh,
you're
it's
not
not a
allowed to
room?
have your phone?
No, they take your phone away.
Why? Is there
They-
like confidential stuff you hear about?
No, not really. They
Just
want
how
you
it's
to
like-
they want you to kind of disconnect from home, and they want you to shift
Wanna
your focus
brainwash
over
you.
to the program and embrace what's going on over there. And if you have your phone, you're going to be homesick because you're going to be seeing everything that people are doing, and you're just going to have FOMO.
Are you homesick?
That sounds stupid.
I was for a week, but it's you get
Okay,
used
when
to
you
being
say
gone.
spring
Did you
break,
make
that
any
sounds so dumb.
friends?
DC shifts everything, so
Living, everyone has a different.
Stay busy.
Wait, when did
I'm
your
not out until June,
when
Wait,
did
so-
your school start? Yeah, when did it start?
the end of January.
Wait, so
This is
like,
gonna bug me. Okay. we'll
wait,
get
so
back to
like,
that.
how are you allowed
I
to
don't wanna
leave?
bother
That's
anything,
okay.
so-
Thanks for stopping.
Yeah, just want to say hi.
I wonder if he's allowed to leave. Does he have a curfew?
Okay.
You should ask.
I know, that's what I was trying to ask.
Well, so many questions.
Well, I'm curious.
You should go to.
I should join the Navy. I'm gonna be honest.
Morella, you seem like a Navy.
No,
person.
That kid just.
She would die.
And as soon as someone yelled at me, I would start crying. I'm not gonna lie.
Wow, 32 is low key.
If
I got the
anyone
right answer.
raised slightly changes their tone of
Because
voice
I just knew it was. I knew it was
of authority, I can't do it.
No, because it's P over I
Because then
squared,
how do you
right?
get
If
the
I
actual-
squared is the exact same.
You have a
And-
higher
and
P
you
though.
So is there a study session on Thursday?
Holy moly.
Well,
Yeah.
all right, so here's what, so we're gonna kind of start off relatively simple. This is gonna tie this idea of capacitors. So, first what I want you to do is this one where it has like, it's a multiple choice question. And let me give you a hint. So on the one side it says, what is the current indicated by the ammeter immediately after the switch is closed? And then on the other one, you flip it over, it says, what's indicated by the ammeter a long time after the switch is closed? Okay, so that's going to be the situation in terms of those. So try that question.
There's no resistance on capacitor.
No. Just check. Wait, which one? Just check. We're doing both of them.
Both of them, it's just this page, yeah.
Either one.
The second one? Zero.
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 Two? Is it two?
We'll figure it out.
The second one or the first one?
The second.
What's the second one?
When it's closed?
Yeah, it's when it's closed after a
it's
long
closed for a
time.
long time.
Did you get two?
Close for both.
Okay, cool.
Which one are we going to?
Alright, bet. Can you do 6 and 2?
Yes, I did.
Wait, why is it two?
Because after it is closed a long time, then the capacitor becomes fully charged, and then the electrons don't want to go in that direction. So then
Oh, so it just
it'll
goes
just
through.
go over there. Yeah.
Oh, yeah, okay. I had the full.
I always like solve for I equals B with the R, because I always forget the
Isn't it
first.
gonna be 20? Why? What's the
I don't
same
know.
on the
Yeah, I know it's the same thing, I never do the first one actually.
When do you beat?
31.
No, the actual.
I kind of want to watch like Harry Potter or Hunger Games. I feel like those are just the vibes. You know what I mean? Okay.
I watched the Hunger Games in English.
Yeah, we're watching it right now, and I'm like, wait, this is kind of good.
Okay, so here, what's the fundamental, so are we going?
Yes.
Okay, so what's the fundamental difference between the two problems?
A long time and immediate.
But what does that impact?
The charge of the capacitor.
Okay?
Whether it lets through electrons or not.
Exactly. It's
Yeah.
whether or not it allows electrons to flow through. So immediately, boom, we close it, okay? So is electricity going to flow through the capacitor?
Yeah.
Yes. So then you have these that are in parallel. So you can take 1/6 plus 1/12, and the inverse of that, you're going to get 4. You have a 24-volt battery, you're going to have
6 amps.
6 amps. Okay? So there's that one. Then, after it's run a long time, then what's going to happen?
It's not gonna let anything through.
This is completely charged up. No electricity is going to flow through it. Then what's going to happen?
It turns into a
12.
Then it's just a... Now, will any current flow through that 6 ohm resistor?
No.
No, it's all going to flow through that
Yeah.
12 ohm resistor. Therefore, the current drops down to 2 amps. Got the difference between those two?
Yes.
Okay. So, try the question with the bulbs.
I've been trying.
The AP one?
Yeah.
Oh, I guess they both are.
So try the question with, I promise you, there's gonna be a question like this, number 5, with the bulbs. Mark my words. Okay, so when you get to part A, determine the average potential energy change. Now, the whole key to this is you're talking about an electron. So this electron is going, so this is the actual path of what's happening, right? So here's the story. All you have to do is use U equals Q delta V. So what's the charge on a single electron, Louis?
1.6 times 10 to the negative 19.
Coulombs times,
24 volts.
and 24 volts is the same thing as joules per coulomb. Multiply that all together, you get
3.8
What's your
times 10 to the negative
3.8 times 10 to the negative 18th joules. So that's how much energy that thing is losing as it makes that path. Now, the whole key to this is that it's talking about does the electron gain or lose potential energy as it moves from Z to X? Because you're talking about electrons, so what's it going to do?
You are bugging.
It's going to
Lose?
lose.
Okay.
Okay?
Wait, what's that?
So on part 2, it's going to lose electrons. If you're talking about electrons, this thing is going to lose energy as it goes up. Now, when is it going to gain that energy back?
to the battery.
Then it's going to gain that energy when it goes back through the battery. So what do you have for B, the equivalent resistance of the entire circuit?
10 ohms.
10 ohms. Fantastic. Okay? So you got the two that are in parallel, and then you're going to add those together in series, and so you get a grand total of 10 ohms. So based upon that, okay, now, here's the whole kicker. Knowing that it's like having one single 10 ohm resistor. So then what would be the current through it if it was just one 10 ohm resistor? 2.4 amps.
Yes.
Okay? So you're going to need that number. Okay? They don't direct you to ask you to find it, but you're going to need that number. So then, how'd you get the current flowing through point Y?
3 over 9 times, 6 over 9 times 2.4.
Yeah.
What?
With the calculator?
You do 1 minus 3 over 9 and then 2.
Well, because it says calculate the magnitude of the current flowing through Y.
Yeah.
Sorry, I was looking at parts.
I just did 130.
So what'd you get?
1.6.
1.6 amps. That's cool.
Yep.
Now, on part C, II, indicate on the diagram the direction of the current through point Y.
Down.
Clockwise.
So technically, if you're talking about current's going to be going like this.
Okay, we're looking at
Okay? So that's what you have to watch. If it's talking about current, that's the old school way. It goes from the positive round. If it's talking about electrons, it's going to be going in the opposite direction. So calculate the energy dissipated in the 12 ohm bulb in 5 seconds.
153.
So, what'd you get?
153.6.
Yeah, 154. Okay?
What's that value right there?
What do you mean?
3.8 times 10 to the negative 18.
Oh, that was that answer to that first question of the potential energy change.
Oh, okay.
So then that answer to D is going to be 154 joules, because you figure you find your watts, and you can use PIV, you can use I squared R, you can use V squared over R, it doesn't make any difference. So whatever works for you, should get 154. Now, here's the big one. What do you have for your ranking?
0.
So help me, Louie. If you put 0 on any of these,
Not even believe.
I put 4, 3.
it says with 1 being the brightest.
Oh my god.
See, it doesn't
Fourth.
say off.
So what do you have as your sequence, Marilla?
4, 3, 1, 2.
Perfect.
Wow, I love this unit. It is quite fun. Like, I actually kind of get it.
Maybe you're destined to be an electrical engineer.
I don't know.
Now, if you just want to do smash mouth physics to figure that out, that's what I did. I went through and I calculated the power dissipated in each one of those. Now, in the name of time, okay, because this deals with capacitors and it's just variables. So do this one. It says 2016 Physics 2 free response question. It starts off, some students are investigating the behavior of a circuit with 4 components. Try that one. That one's a doozy.
It's a doozy.
Which one?
It's 2016 Physics 2 free response. Okay, so we're working 2016 AP Physics question 2, where it has the circuit with 4 components, resistor, capacitor, and a battery, and a switch. So again, here's the recurring theme. Immediately after the switch is closed. So your current, right? So if you look at Ver, so immediately after, it's just like the capacitor isn't there. Okay? It's like it's not there. So there is, all that current is flowing through it, nothing's happening. So in that situation, would it ask the potential difference across the capacitor? So the potential difference across the capacitor is going to equal 0, okay? Because it's just like it's not there. But then, when it talks about the current, so then if you look at this in terms of I, and you Ver it up, then your current is going to be your voltage divided by your resistance. If you wanted to put that as your electromotive force over R, that's cool too. Okay, so you can put either one of those. Now, when it gets to part 2, determine the current in the resistor, it's the exact same question. So once it's run for a long time, now what's going to happen? The capacitor is going to be fully charged. What's going to happen to the current in the resistor?
0.
It's going to be 0. But then what's going to be the voltage drop across the capacitor?
E.
That's going to be the same as the battery. Okay? Cool with that one?
Yeah.
Got that one. Now, when you get to B, okay? So here's the story. We're going to let this go. The whole point of capacitors in terms of energy is to store that. Okay, if you go with the dam analogy, storing water, storing a certain amount of potential. So then you're going to total energy stored of the 2 capacitors now U2. So here's what's going to be different. So we're going to put this thing in series. So now you're going to have 2 capacitors that are in series. There's your switch, there's your resistor, okay, whatever. Now, here's the deal. When they're in series, and this is what I showed you all yesterday, how much voltage is across each one if they're in series? All of it or half of it? Half. Each one stores half the voltage.
For capacitors?
Yes. If they're in series, each one of these is holding half the voltage. If it's just one of them, the voltage is the same as the battery. But if you have 2 capacitors in series, each one is having half the voltage. Now, if you look at how you calculate U, right? So you have 1/2 C V squared. So because of the fact that you have V squared, if you double that voltage, what's going to happen? It's going to go up by a factor of 4. Okay? So here's the story. So with this one, you're told that they're both going to have the same capacitance. So if you look at this, so U1 is just going to be 1/2 C V squared. Okay, that's it. That's the potential energy stored in it. There's the capacity. The voltage is the same as the electromotive force of the battery. Okay, same thing. Now, when you have U2, So what you're gonna have here is a situation where you're gonna have 1/2 the capacitance, but then you're gonna have V over 2, but that's going to get squared. But you're gonna have 2 of them. So each one of those is going to be holding half that capacitance. So when you do this, you get 1/2 C V squared over R plus 1/2 C V squared over 4. I don't know why I said
So they don't
R.
hold half the capacitance, they hold half the potential energy?
Yeah, so, no, hold on, what'd you say? Say that, run that by me again.
So they don't hold half the capacitance, they hold half the potential energy.
They hold half the voltage.
Wait, is it an eighth?
Huh?
I did. Wait, is it 1/8?
Hold on.
Because I just put in C over 2 because I did my capacitance, like my equivalent capacitance, and then plugged it into there. Can you do that?
No,
You can't.
because each one is still gonna have the same capacitance,
Oh, okay.
but they're gonna have half the voltage.
So I have to separate it?
Yes.
Okay.
So when you do this, you get, and then you add these together, right? So then this whole thing is CV squared over 4. So now if you're going to try and find that ratio, so the first one is 1/2 CV squared, okay? So that's U1 by itself. And then the second one is going to be CV squared over 4. So this flips up. You get 2 CV squared over CV squared, otherwise known as 2.
Okay, cool.
Because
Yes.
when they're in series, they're going to have the same capacitance, but they're going to have half the voltage.
Yeah.
Okay? But it's talking about, so each individual one, okay, so that's what you want to take in mind. Are you talking about the individual ones, or are you talking about the sum total of the 2 potential energies across them? Now, the whole kicker to this is C, which
Okay,
is what
so-
we've been leading up to.
Sorry, so is the one capacitor gonna have more overall U than the 2 put together? In series, sorry?
Yeah.
Yeah.
Yeah, because that's that ratio. So
But
the
you
one
just
by
saw-
itself is in effect CV squared over 2.
Okay,
The 2 together are CV squared over 4. So the
Gotcha.
one by itself,
so it's a 2-to-1 ratio.
Yes.
So the 1 to 2, gotcha.
yeah. So now give C a try. See
Wait,
how
what
that
about
goes.
B2?
Huh?
B2? Talking about area and distance. Do we have to know about that?
Now don't worry about B2. Don't worry about B2. Move on to C.
Back. Are we gonna do the back side of this?
Yes. Well, we have time. But try C. Yeah, don't worry about B2. I won't give you anything like that on the test.
B2?
Yeah,
Okay.
but I do want you to be able to think through C.
Man.
And you don't have to write out the paragraph explanation.
Okay.
was thinking it was telling us to add a resistor.
Okay.
Where's your capacitor?
Huh?
Where's your capacitor?
Oh, is that the answer?
No,
Oh.
I've got it drawn the capacitor.
So is it, wait, that is the answer? Oh my gosh.
No.
Is that
I've
the
done
answer?
it, but I haven't.
I did it right. And I wasn't even looking at the board. Well, I didn't I didn't put in the switch though. So I probably need that, but
Okay, so Morella started that up. So,
sorry guys. Just know that that is the number
okay, let me
one.
explain it again for the studio audience. So with this one, that capacitor is not fully charged. It's gonna flow through here, no electricity. As that gets more charged, it's gonna force it over here. And so this is gonna start dim, get brighter. This one is gonna go bright and then get
Dim.
dimmer.
Yes.
Okay.
Can we, is there gonna be a question like, beat alive?
No. You said
Like which one?
Beat alive?
No, you said there won't be one like that.
No.
On
you
the
said there
test
wouldn't
even?
be.
Hold on, which one? I didn't hear what you said.
It's not
Me
gonna be a
too.
question on the test like beat alive, right?
No,
Okay.
no. You have to know the factors that play out with capacitors? Yes. So what I'll do, in the name of time, I'll scan you that answer to to the other two questions that we didn't get to, and I'll just send you those in
Scan us
an
all the
email.
answers.
Any tips and tricks for certain things to look at, especially?
How do you calculate, what's the two ways you can calculate volume?
Volume.
Area.
Area.
Cross-sectional area times a
Length.
length, or length times width times
Height.
height. Remember, resistance equals rho L over A, which you can also write as.
Something.
So
Rho
if you
times
solve this for
volume.
area,
L squared over V.
you can write that as rho L squared over V. That might be handy to keep in mind.
Okay.
Are you gonna give us that?
No, I'm just telling you, that
Oh,
might
you're
be
not
good.
going to give it to us though?
What I might tell
That's on
you,
the sheet.
what I might remind you, Louis, is that volume is area times length.
I might have a great reminder, actually.
I might remind you of that.
Oh, you said that's volume? Oh,
Yes.
okay, I thought that was.
Wait, this test, is this over current too?
I was a little bit.
It's over current.
Yeah. I thought
That
it
whole
was-
thing we've been going through, right?
Yeah.
Okey doke.
What?
Okay, so.
Test on Thursday.
Wait, what'd you get?
What time do we study, what time do we stay tomorrow night?
5.
Minus.
Okay, study sesh tomorrow, 5 p.m. See
But
you
tonight
guys.
is at 6.
Yeah.
Bye.
Code word is chef.
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 At least we don't have to
Chef.
study this
Chef.
but you're happy about it.
Chef.
Cause
Is that all?
Yeah, that's all.
Okay.
Mr. Burkamp is cooking today.